Okay, hi everyone. So from the previous video, we had downloaded and prepared our data, you know, including, you know, um, scaling, uh, scaling all the variables so that they're easy to visually inspect. Mathematically, it doesn't make any difference, but it's easier to inspect that way. Okay, so you scale the data. Now we have the data with us. It's ready to go. The first thing you're going to have to do in this exercise is to test for stationarity, right? So first, we're going to go use Dickey-Fuller uh, test, okay? The command is dfuller variable name. And then the option regress is just to show the regression results as well, instead of just showing the Dickey-Fuller test. So yeah, okay, so I just asked you to do Dickey-Fuller. Fine. Okay, you may choose to do the augmented Dickey-Fuller, but that would require a little bit more knowledge in terms of choosing the lag length. So in this exercise, we're not going to do that. Just do Dickey-Fuller. Okay, so let's do that. Test Dickey-Fuller for stock price, Dow Jones, and T-bond. Okay, I'm wondering if Stata lets you do all three at once. So I'm going to just try anyway. Dfuller. So the command is dfuller. You're going to have Amazon, DJIA scaled, T-bond scaled. I wonder if it does that. Nope. So it lets you do only one at a time. So Amazon price, Dickey-Fuller, from the previous video, you'll notice that, yeah, it's not stationary. So you're going to report this result, circling the p-value. P-value is much higher than the acceptable significance level. So we're going to conclude that Amazon price is non-stationary. Okay, let's do dfuller on DJIA scaled. Now, scaling makes no difference on the test for stationarity, okay, because we're just multiplying the number by a constant. It doesn't affect the the um the results here. Okay, so let me put also the regress function, regress option. So it's the same test, right? T statistic is much lower than any critical value, which means that we're gonna not reject the null of unit root. We're gonna say that this is non-stationary. You can look at the regression result here as well. Okay, so DJIA non-stationary, stock price non-stationary. Yeah, so already we know that if we estimate the model, we're going to get spurious results, spurious regression, and because we're going to show statistical significance even when there's no relationship. Okay, let's test also for T-bond. Right, so T-bond also non-stationary. So all three variables are stationary. Let me show you something really quick, just to show you why stationarity can affect your result. Non-stationary data, uh, when the time series are all non-stationary, you could get spurious results, concluding relationship when there is none. So let me show you the scatter plot of uh, Amazon price with the T-bond. Okay. Now, the relationship should be opposite based on theory. High yield should lower the price of stocks and so on. But if we do this, take a look at the scatter plot, what it's going to look like. Okay. It doesn't show clearly the downward relationship. Okay. But this could be misleading, right? It's hard to say whether the two have any relationship. It seems like it could be straight or both. Sorry, it could be just no relationship. It could also be a little bit upward. Okay. So let me show you Amazon price as well as the JIA. Clear upward. Okay, clear upward. Now, the results here that we can show, if we show here the upward, the positive correlation here could be spurious because as you can see, both of them are experiencing an upward trend. Okay, remember that we plotted the TS line before, and we showed that both the Amazon price and DJIA have an upward trend. Okay, so that's kind of beside the point here. Thing is that we tested for not for stationarity. In my case, none of these variables are stationary. Next, let's test for trend stationarity for all the variables. In particular, we're going to include the trend in the command. Yeah. So we're going to go dfuller, Amazon price, include a trend. Let's see what happens. Is the data stationary around a trend? Okay. Has result p-value 0.94, not trend stationary. Okay. Now do the same for DJIA. Getting pretty close. The p-value is still not significant, but it's lower. So DJIA seems to be driven a lot by the trend, right? But still, it's still non-stationary, even if we're controlling for the trend. Now let's do the same for T-bond. Okay, T-bond is even closer to being trend stationary, right? Because the p-value is about 20%, right? 20%. So the T statistic here is close to being significant, but still not quite. So for trend stationarity, all three variables are non-trend stationarity. So even if we control for trend, the regression result will still give us spurious results. Okay, concluding relationship even when there is not. Okay. Okay, trend stationarity. The next one asks you to do different stationarity. So basically, we're going to test the difference, test the stationarity of the first difference. Okay. So in the lab instructions, I give you the instruction to generate a new variable, then do dfuller on that variable. Alternatively, you can just run the dfuller test directly without generating. So you're going to use the d dot operator. So let's do dfuller, Amazon price. Now, instead of Amazon price, I'm going to put d dot. Okay, this means the first difference of Amazon price. Okay. Dfuller test statistic, a lot bigger than the 1% significant critical value. So this is highly significant. We reject the null of non-stationarity. So in this case, the first difference of Amazon price is stationary. Okay, do the same for DJIA. Is the first difference stationary? Yes. P-value goes to 0, stationary. Okay, and then let's try for T-bond. Stationary as well. Okay, so all these guys, the first difference for each variable is going to be stationary. So when we want to analyze, we want to estimate the ARDL, we have to use first difference, right? Controlling for the trend doesn't work because it's not trend stationary. It's different stationary. So using the difference value would give us non-spurious results. Okay, so that should be all for this portion of the video. Next, we're going to estimate the ARDL model.